Welcome to YouTube channel Linga Reddy Chemistry J NEET. Today topic is Biomolecules Lecture 1. Lecture 1. The main subtopics are there as follows: carbohydrates, proteins, nucleic acids, vitamins. These are the main topics in this. The proteins generally is the amino acids is the main topic here. The carbohydrates, we will learn about glucose structure, fructose. Okay. The nucleic acid, RNA, DNA, the basic components. Vitamins, we will learn in vitamins. Okay. In the amino acids, essential amino acids, non-essential amino acid, how the protein is forming. The protein, what is the classification is there. Okay, how the protein is forming, what is the function of the proteins. These things we will discuss in this. It is looks like a biology topic, but biology and chemistry mixed. The present chapter is biomolecules. See, the biomolecules are, before going to that biomolecules, we had to know little biological definitions. See here, a living system grows, sustains and reproduce itself. Living system, suppose heart is there, nerves, okay, liver is there. The liver, these are growing and sustaining and reproduce these things. So further, these are using some molecules, that those are composed of non-living atoms. Non-living atoms and molecules से वो formation होता है, those molecules are utilized and forming a living organism. Okay, so this studies comes under biochemistry. Okay, those molecules are generally carbohydrates, proteins, nucleic acids, lipids, etc. Okay, these are individually non-living beings, but in a living being, so these all are present. Okay, that is the main difference between organic compound and biomolecules. Now first topic here, carbohydrates. The name came from the carbohydrates, hydrated means carbon and some H2O molecules are there, XH2O. So CxH2OY, you can see the formula like this. Suppose if you write the glucose C6H2O6, so this formula generally C6H12O6. Okay, so this glucose, they thought initially it is the hydrated molecule of carbon. It is the hydrated molecule of carbon, like copper sulfate 5H2O is there, 5H2O. This is by heating, this is actually blue color hota hai. By heating it becomes white color. What's happening here? Copper sulfate plus 5 water molecule, this water molecule is getting separate. It is a white color, colorless ban raha hai. If you put it in the water again, it will get blue color. Again hydrated copper sulfate is forming. This is the hydrated compounds. But in case of this carbon hydrate, if you heat it, you will get only carbon, CX, plus H2O getting separate. But the thing is here, if you put this CX in the water, you won't get it back. This glucose. So that is the main difference here. That's why they thought initially carbohydrates, but these are not carbohydrates. However, these are not carbohydrates. Even though the name is already given, so it is still, the name is not changed. Carbohydrate, hydrated carbon. Okay, like that. But it is not actually carbohydrated molecule. Okay, it looks like that. So have you understood what is the hydrated compound and non-hydrated? Hydrated compound means generally by heating water molecule is living. Again when you pour some water, it will get it back, the same structure. Those are hydrated molecules. Okay, same FeSO4 is there. FeSO4 is dot 7H2O is there. Okay, many hydrated salts are there. Even Na2CO3 also, washing soda, Na2CO3 dot 10H2O is there. Okay, like that many hydrated. By heating, these 7 water molecules are living, then it becomes again colorless. Okay, it is a green in color. Okay, again if you put it in the water, again it is getting same color back. These are the hydrated molecules. Now, classification of carbohydrates. The classification of carbohydrates: monosaccharides, oligosaccharides, polysaccharides. The carbohydrates are classified on the basis of their behavior on hydrolysis. They have been broadly divided into following 3 categories. Monosaccharide means the carbohydrate that cannot be hydrolyzed further to give a simpler unit of polyhydroxyaldehyde or ketones is called a monosaccharide. Suppose, so these are the monomers. This is the dimer type. Okay, so this is the disaccharide. Disaccharide matlab it is by the hydrolysis giving 2 separate units. Okay, again if you put it in the water, this glucose in the water, it is not giving any units. Means furtherly it is not hydrolyzed. Furtherly it is not hydrolyzed. This is hydrolyzed. Okay, this is it is giving 2 components, that's why it is a disaccharide. This is the disaccharide, but it is giving only one, that is monosaccharide. That is only monosaccharide. It is not furtherly decomposing or hydrolyzed. Now, if it is giving 3 to more than 3 to 10, those are known as oligosaccharides. The carbohydrate that yield 2 to 10. So 2 to disaccharide. So 2 onwards, 3, 4, 5, 6 it is giving, those are oligosaccharides. Then polysaccharide means more than 10 is there or large number of monosaccharides are giving, that is polysaccharides. Okay, this is the main basic classification here. Then monosaccharides example. The monosaccharide, if it has 3 carbons, that is called triose, 4 carbons tetrose, pentose, hexose, heptose. इसमें aldehyde है तो aldo triose, ketone है तो keto triose, aldo tetrose, keto tetrose, aldo pentose, keto pentose. Like this you can classify aldoses and ketoses, aldose and ketose groups. Now, first compound we are discussing, that is glucose. It is a monosaccharide. The glucose occurs freely in nature as well as in the combined form. It is present in sweet fruits and honey. Ripened grapes also contain glucose in large amounts. It is prepared as follows. इसमें fruits में we will get some sweetness. The sweetness is due to this glucose. Okay. As well, direct if you want glucose, maximum we will prepare from cane sugar. Sugar cane बोलते हैं इसका, cane sugar. From sucrose in the cane sugar, whatever is there raw material, that is sucrose. Okay, by the hydrolysis we will get glucose and fructose. That's why it is disaccharide. Okay, by the hydrolysis we are getting glucose and fructose. Now from starch में maximum glucose only, there is no fructose. Actually sweetness में this is the sweeter we can see, because fructose से भी ज़्यादा sweet वाला है, that's why it is sweeter. The sugar cane very sweet, that is due to fructose, not because of glucose. Okay, glucose is not that much sweeter. Next, from starch. In the starch, maximum glucose molecules, not maximum, full, only glucose molecules are there, but this is a polymer. Starch is the polymer. It is giving by the hydrolysis only glucose molecules. Now we are discussing about structure of the glucose. How the structure of glucose is there. Glucose is an aldohexose. Aldohexose is also known as dextrose. Why we are talking dextrose? Why we are calling it is dextrose? It is this solution is optically active compound. It rotating clockwise. Dextro means clockwise rotation. Okay, levo means anti-clockwise. Fructose is levo. Okay, glucose is dextrose. It is the monomer of many of the larger carbohydrates, namely starch, cellulose. Okay, these both are polymers. Starch is a combination of glucose only. Even cellulose also we can see in the plants. Plant cell has cellulose. It is probably the most abundant organic compound on the earth, because all plants, without cellulose there is no plant, there is no leaf, there is no branch. Okay, that's why this glucose maximum is there on the earth. It was assigned the structure given below on the basis of the following evidences. Okay, nowadays we know that C6H12O6 is there. C6H12O6. If you write the structure like this, we will write one of the structure: HOH, 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 then HOH, then here CHO. See, 2 times HOH, HOH, एक बार उल्टा लिखना है, फिर सीधा लिखना है CHO. This is the glucose structure. 1, 2, 3, 4, 5, 6 carbons. So ये glucose है, aldehyde functional group is there. तो सबसे नीचे alcohol होगा, बीच में HOH, HOH, एक बार उल्टा, एक बार सीधा. Okay, this is the glucose structure. But how you came to know this is the linear, and step by step we are discussing here. Okay, first of all, it is molecular formula was found to be C6H12O6. ये तो molecular formula पता चला है. कैसे पता चला है मतलब? So many methods are there. Even we discussed in the solution chapter, unknown compound molecular mass we can calculate by colligative properties. Okay, and later we can do some tests, chemical tests. Okay, finally concluded that 6 carbons, 12 hydrogens, 6 oxygens are there in the molecule. Then how those are arranged? Is it in the linear shape or branched chain is there? How those are arranged? Step by step we will learn few things. On prolonged heating with HI, reaction with HI, it forms N-hexane, suggesting that all the 6 carbon atoms are linked in a straight chain. What we are doing, this C6H12O6 is treated with HI and heating. HI is the strong reducing agent. It can convert even carboxylic acid into alkane, aldehyde into alkane, alcohol into alkane. सबको alkane बनाते, इतना strong है. We know that lithium aluminium hydride LAH is strong, but LAH up to alcohol तक कर सकते हैं, alcohol तक. But HI can convert into alkane. Okay, so if you react with glucose and HI, then it is forming alkane. The alkane also N-hexane बन गया. N-hexane बन गया means in the given compound it is a linear structure. It is a linear. Suppose इसमें branch है तो branch मिलेगा हमको. इसमें linear है इसलिए we are getting linear shape. N-hexane. Okay, this is the one evidence. All 6 carbons are in the linear structure. Now, glucose reacts with hydroxylamine to form an oxime and adds a molecule of hydrogen cyanide to give cyanohydrin. These reactions confirm the presence of carbonyl group in glucose. In the last chapter also we discussed, whenever NH2 group and this carbonyl group is there, just removing one water molecule, those are forming, like these oximes are forming. Okay, so this is the evidence here. This hydroxylamine is reacting with this compound means one aldehyde or ketone group is there. This much confirm. Okay, confirm the presence of carbonyl group is there. Okay, next, it is also reacting with HCN. It is also reacting with HCN. So one more time it is confirmed that carbonyl group is there. Next, glucose gets oxidized to 6 carbon carboxylic acid. Glucose gets oxidized to 6 carbon carboxylic acid, that is gluconic acid, on reaction with mild oxidizing agent like bromine water. Bromine water is just mild oxidizing agent. This indicates that the carbonyl group is present as an aldehyde group. Suppose ketone is there, ketone to carboxylic acid it's not forming. Okay, carboxylic acid बनना है तो फिर it will be break up. Only KMnO4 के साथ हो सकता है. But aldehyde में just aldehyde is this one, carboxylic acid is easy to oxidize, aldehyde to carboxylic acid by mild oxidizing agent. That means it indicates that aldehyde functional group is there. वो हाइड्रॉक्सिल अमाइन से क्या पता चला हमको? हाइड्रॉक्सिल अमाइन से एक कार्बोनाइल ग्रुप इज देयर, इतना पता चला. इट मे बी आल्डिहाइड और कीटोन, ऑल भी हो सकता है, ओन भी हो सकता है. लेकिन द सेकंड नेक्स्ट रिएक्शन इज ग्लूकोनिक एसिड फॉर्मिंग बाय रिएक्शन विद ब्रोमीन, द माइल्ड ऑक्सीडाइजिंग एजेंट. दैट मीन्स आल्डिहाइड फंक्शनल ग्रुप इज देयर इन द गिवन कंपाउंड. नेक्स्ट एविडेंस, fifth, very important, the acetylation of glucose with acetic anhydride gives glucose pentaacetate, which confirms the presence of 5 OH groups. Since it exists as stable compound, 5 OH groups should be attached to different carbon atoms. Okay, in the organic chemistry we learned, suppose on same carbon 2 OH groups are there, this is unstable, immediately giving removing water molecule carbonyl. But these all 5 acetates, see, whenever NH2 and OH groups are there, acylation takes place on these groups because here lone pair is there. Okay, so N C double bond O CH3, O is there, O C double bond O CH3, like this acylation and acylation takes place on nitrogen and oxygen. So here 5 times acylation took place, that means 5 OH groups are there. Then next doubt is, these 5 OHs are there on different carbons or same carbon? If it is on same carbon, it should be release water molecule should form carbonyl, but carbonyl is not forming. That means all 5 OH groups are at different positions, at different carbons, okay. So this is the one confirmation. First of all, 5 OH groups are there, those are at different carbons. Next, sixth, on oxidation with nitric acid, nitric acid is a strong oxidizing agent होता है, strong oxidizing agent. Glucose as well, gluconic acid, both yield a dicarboxylic acid, that is called saccaric acid. इसके पहले आ गया था gluconic acid, now it is saccaric acid. This indicates the presence of a primary alcoholic group in glucose. Okay, what we are doing this, already gluconic acid was there with bromine water. Okay, this bromine water oxidized gluconic acid reacting with HNO3, it is forming saccaric acid. Without bromine water, direct HNO3 also, it is giving saccaric acid. Okay, with bromine water we came to know that one is aldehyde group is there. With concentrated HNO3, same number of carbon, carboxylic acid is forming, means the other functional group, it may be alcohol. The other functional group would be alcohol. Because alcohol can convert into carboxylic acid with strong oxidizing agent. ओके, मीथेन है तो नहीं होगा ना, दैट इज द रीजन. So the exact spatial arrangement of different OH groups was given by Fischer after studying many other properties. Its configuration is correctly represented as 1. So gluconic acid is represented as 2 and succaric acid as 3. So you may ask doubt, sir, OH right side है left side है कैसे? So this thing not given in the syllabus, you no need to worry about that. So they did so many experiments, finally they concluded. So important points only we are discussing here. Of course it is not our syllabus. Okay, whatever given in the syllabus, that things we have to discuss, we have to learn. So this OH right side left side, they did so many experiments, they decided. So now finally concluded that the first one, now see here, the first one is glucose, the second one is one side gluconic acid, you can see here gluconic acid. The third one is succaric acid. Succaric acid. This is the gluconic acid. वो structures these are the. See aldehyde में with bromine water, just this aldehyde easily it oxidizes to carboxylic acid. Then furtherly with HNO3, this alcohol also converted into carboxylic acid, so it is succaric acid. Next, glucose is correctly named as D plus glucose. Here D before the name of glucose represents the configuration, whereas plus represents dextrorotatory nature of the molecule. It may be remembered that D and L have no relation with the optical activity of the compound. The meaning D and L notation is given as follows. See here, the D means right side OH group is there, that's why D. If it is left side is there, capital L. In the last chiral carbon CH2OH, suppose here OH left side is there, this is called capital L. Okay, the plus and minus is indicating optical activity, there is no bracket here. The plus and minus indicating optical activity. Plus means dextro clockwise rotation, minus means anti-clockwise rotation, levorotatory. Okay, next, the letter D and L before the name of any compound indicates the relative configuration of a particular stereoisomer. This refers to their relation with a particular isomer of glyceraldehyde. Glyceraldehyde contains one asymmetric carbon atom and exists in two enantiomeric forms as shown below. You can see that this glucose is similar structure with glyceraldehyde, So glucose structure, what I written here, CH2OH, HOH 2 times, then one time HOH is opposite, then again same, then here CHO, right? So you can see here this similar structure is there. Relative configuration, ये glyceraldehyde में क्या है, CH2OH, next HOH, right side is there, it is the right side is there, here also right side is there. Okay, so it is similar to glyceraldehyde, that is indicating D. Okay, in case of glyceraldehyde, plus means D actually. Okay, but in case of glucose में ये capital D means this not indicating optical activity, it is indicating that it is similar to glyceraldehyde plus glyceraldehyde. It is similar to plus glyceraldehyde. Okay, so glucose में D plus glucose भी हो सकता है, D minus glucose भी हो सकता है. ठीक है, So this plus indicating clockwise rotation, this minus indicating anti-clockwise rotation, optical activity में. Okay, the capital D indicating plus glyceraldehyde, capital L indicating minus glyceraldehyde. Okay, next, cyclic structure of glucose. Cyclic structure of glucose. The structure 1 of glucose explain most of its properties, but the following reactions and facts could not explain by this structure. The first one is, despite having the aldehyde group, glucose does not give 2,4-DNP test and skips test. It does not form the hydrogen sulfide addition product with sodium bisulfite. Aldehyde is there, we are writing. If aldehyde is there, it should give the Tollens skips 2,4-DNP. 2,4-DNP is the main test. 2,4-DNP is the functional group test of carbonyl compounds. Okay, but this compound is not giving 2,4-DNP test. Not only 2,4-DNP, it is not giving skips test also. But note point here, Tollens is giving. Okay, skips is not giving, Tollens is giving. 2,4-DNP तो main functional group है, वो भी not giving. Sodium bisulfite is the addition reaction, it should give, but it is not giving sodium bisulfite test also. Why? Later we will know that. Second point, the pentaacetate of glucose does not react with hydroxylamine, indicating the absence of free CHO group. Okay, pentaacetate. Okay, 5 OH groups are there, we came to know that. So whenever this pentaacetate of glucose is there, that is not react with hydroxylamine. Normal glucose is reacting with hydroxylamine, but pentaacetate glucose is not reacting with hydroxylamine. That means CHO में कुछ ना कुछ प्रॉब्लम है, कभी रहता है कभी नहीं रहता है. Okay, then the third, glucose is found to exist in 2 different crystalline forms which are named as alpha and beta. See, crystallization form में generally एक compound लेते तो एक ही crystal होगा. But here 2 types of crystals are forming. The alpha form of glucose, the melting point 419 Kelvin, is obtained by crystallization from concentrated solution of glucose at 303 Kelvin, while the beta form melting point 423 Kelvin is obtained by crystallization from hot and saturated aqueous solution at 371 Kelvin. Okay, so here we are taking the crystallization 2 different methods. Okay, one is alpha and one is beta. Okay, alpha का melting point हो रहा है 419 Kelvin, बीटा का melting point है 423. See, almost 4 degrees Celsius variation is there. The beta is forming by crystallization of concentrated solution. Concentrated solution से बन रहे, वो भी at 303 Kelvin में we are doing this crystallization. So these beta crystals are forming at 371 Kelvin, from hot concentrated, hot saturated. These are the concentrated solution. It is a saturated aqueous solution से बन रहे. So this is the main difference. Alpha glucose crystals and beta glucose crystals. ये दोनों का melting point में variation है. But variation क्यों? Because we are crystallizing at different conditions. At 303 Kelvin में concentrated solutions में we are crystallizing. That time one compound is forming. That compound melting point is 419 Kelvin. We are doing the crystallization at 371 Kelvin at hot saturated aqueous solution में. So we are getting one new compound that the melting point is 423 Kelvin. ये दोनों का 4 degree Celsius variation है. Okay, so that means something is there here in the aldehyde functional group में. This behavior could not be explained by the open chain structure of glucose. It was proposed that one of the OH groups may be added to the CHO group and form a cyclic hemiacetal structure. One of the OH group is added to CHO group. Acetal and hemiacetal we discussed in the last classes. It is the aldehyde. Aldehyde reaction with ROH. It is forming hemiacetal. OR and OH. Okay, this is the hemiacetal. इधर भी OR बने तो that is acetal. Okay, ketal भी ऐसा ही बनते हैं. So that means OH is reacted with aldehyde and forming hemiacetal structure. It may be forming. It was found that glucose forms a six-membered ring in which OH at C5 is involved in the ring formation. This explains the absence of CHO group and also existence of glucose in two forms as shown below. These two cyclic forms exist in equilibrium with open chain structure. See, this is the open chain structure. ये fifth carbon में this OH group is attacking at this carbonyl group. So here ring is forming. After forming the ring, you can observe here OH is inside the ring, OH is outside the ring. Okay, if OH is inside the ring, if OH is inside the ring, that is inside means अंदर, हिंदी में बोलते अंदर. So अंदर है अल्फा, बाहर है तो बीटा. बाहर OH ग्रुप है तो बीटा. बाहर ओके, अंदर. ये रिमेंबर करने के लिए एक तरीका है. अंदर अल्फा, बीटा, बाहर. बस रिमेनिंग स्ट्रक्चर एज इट इज सेम है, इतना ही डिफरेंस है. सो दैट्स व्हाई वी आर गेटिंग टू डिफरेंट क्रिस्टल्स. ओके, दीज ऑल थ्री आर इन इक्विलिब्रियम. मतलब एक कंपाउंड ले दे तो ये कंपाउंड भी एग्जिस्ट होगा, एक कंपाउंड भी एग्जिस्ट होगा. और डिपेंड ऑन द कंडीशंस. सो इसका वजह से वी कैन एक्सप्लेन फ्रॉम दीज स्ट्रक्चर्स. स्किप्स व्हाई इट्स नॉट गिवन मींस सो देयर इज नो ऑल्डिहाइड हियर. ओके, तो 2,4-DNP क्यों नहीं दिया, वो भी सेम, देयर इज नो ऑल्डिहाइड ग्रुप. फिर टोलेंस क्यों दे रहे हैं, मतलब टोलेंस इज स्ट्रांग एजेंट, सो इट विल ब्रेक द डबल दिस रिंग and making C double bond O group, making C double bond O group. So it is giving tolerance test. Tolerance तो देते, ठीक है. Skips and 2,4-DNP is not. The two cyclic hemiacetal forms of glucose differ only in the configuration of the hydroxyl group at C1. Okay, just now we saw that structure. Only C1 पे different है, remaining carbon पे same है. The C1 carbon is known as anomeric carbon. The C1 carbon is known as anomeric carbon. So these two structures are known as anomers. These are isomers. In that anomers. Anomer means here alpha form of glucose and beta form of glucose, which are differ in the configuration at C1 carbon. differ at C1 carbon. किसमें differ? configuration में differ. वो right side OH था, left side OH था. The first carbon is anomeric carbon. These two structures are known as anomers. Next, the six-membered cyclic structure of glucose is called pyranose structure. Pyranose, alpha beta in analogy with pyran. ये pyran is this one, वो six-membered ring है. So these structures are known as pyranose structure. It is similar to pyranose, that's why pyranose structure. You can see the cyclic structure of glucose is more correctly represented by Howard structure as given below. Okay, Howard scientist, he given these structures. Okay, in that structure again I am writing here CH2OH, HOH, HOH, HOH. See the HOH here, C double bond OH. It is a open chain. Okay, ये open chain को हम रिंग बनाना है, ये कार्बन से, ये ऑक्सीजन से, ये ऐसा रिंग बनेगा. ठीक है, रिंग बनाने के बाद एक तो OH अंदर भी होगा, एक तो बाहर होगा. अंदर है तो that is alpha. आई एम राइटिंग अल्फा, सी अल्फा में ये राइट साइड है ना, ये राइट साइड ग्रुप सब तो डाउन हो जाएगा, इधर डाउन होगा. ओके, सी हियर. So these all right side groups are down here. You can see I am giving the numbering here. Oxygen attached CH2O here, number 1, 2, 3, 4, 5, 6. Okay. See, first carbon में OH is down, OH down. Next second carbon में भी OH down. Next third carbon में H. Right side is there. All right side is down. Left side is upper. एंड दिस CH2OH कभी भी अपसाइड होगा, अप होगा, इधर ही होगा. ओके, सो लाइक दैट यू कैन राइट दीज cyclic structures of Haworth structures easily. You can write it. So tomorrow we can discuss fructose. Okay, bye. Thank you. Watch the video, like it and share it.